Hello and welcome to our group presentation on thermodynamics. We are a group of students from group 9 and today we'll be discussing about the recent issue of thermodynamic and renewable energy. I'm Nurali Shuada binti Muhammad Samsul, number matrix CD240104, and joining me are our teammates, which is Muhammad Aizat Zulkarnain bin Sabaruddin, Muhammad Al-Ilmi bin Muhammad Adam dan Muhammad Hilman Hishamuddin. So for the next slides is the title of our case study. Okay, so what is the question? Okay, so the question is about the recent issue of thermodynamics and renewable energy. So we got for the case study, which is research how tidal power and ocean thermal energy conversion can be used to generate electricity. Okay, so for the overview, which is as the global demand for clean energy grows, the ocean offers two powerful and renewable options, which is tidal power and ocean thermal energy conversion, which is OTEC. Okay, so for the first, for tidal power harness energy from the natural rise and fall of ocean tides that caused by the moon and sun. Okay, so for the OTECs, which is OTECs generate energy by taking advantage of the temperature difference between warm surface water and chilly deep water, particularly in tropical setting. So for the both technology attempt to cut carbon emission while provide the long-term sustainable energy option. While tidal energy is now used in a number of locations throughout the world, but OTEC is still in its early stage but has enormous future potential. The additional information, ocean thermal energy conversion, which is OTEC, system employ a temperature difference that at least to 20 Celsius or 36 Fahrenheit to power a turbine which generate electricity. Warm surface water is pushed through an evaporator with a working fluid. The vaporous fluid powers a turbine or generator.
Hello. For the first of all, I introduce myself. My name is Muhammad Al-Ilmi bin Muhammad Adam, and my metric number is DD22008T6. Here I present for the description background study. This case study focused on several small island countries in the Pacific Ocean that were previously heavily dependent on imported fuel fossil to meet their energy needs. Several other factors has pushed the country to shift towards more sustainable energy, geothermal installation, high fuel transportation costs. The environmental impact of fossil fuel is prompting a search for alternatives to reduce greenhouse gas emissions and promote sustainable development. In South Korea, specifically in the Siwa Sea, the Siwa Lake Tidal Power Station project has been carried out to produce electricity from the ocean tidal energy. The geography of estuaries channel ocean tide into narrow channels with increasing water velocity is a key factor for efficient tidal power extraction. The kinetic of potential energy of ocean tide can be used to make power. It is called tidal energy conversion. This process relies on the gravitational pull of the Moon and Sun, which cause periodic rise and fall in sea levels. The phenomenon is better known as a sea level rise. Special structures such as tidal ditch, underwater turbine, or tidal fence are installed in coastal areas where the area experiences significant tidal range. Where the tidal occurs, the seawater will flow into the reservoir through turbines that have been built to generate electricity. As the seawater experiences sinkage, the seawater will flow out through the same turbine, thus generating additional electricity. Ocean Thermal Energy Conversion (OTEC). What is OTEC? The system is typically constructed on small islands or nations with coastline. This construction or closed-circle OTEC technology is greatly aided by this temperature gradient value of over 20 degrees C. With this technology, energy will be produced by utilizing the temperature differential between the ocean heated surface water and the chilly deep air. In this process, a liquid with a low boiling point, such as ammonia, is heated by the warm salt water and overpriced. A turbine attached to the generator is powered by the expanding steam. Since ammonia is a working fluid with a low boiling point and high heat circle efficiency, it is the most appropriate material for the system. The circle is continuously repeated by condensing the steam back into liquid using the deeper, cooler seawater. Here are the four purposes of this system tidal energy construction. First, tides occur predictably and regularly over the course of a day, making them a reliable source of renewable energy. Second, tidal patterns are highly predictable using meteorology. Engineers can plan energy generation schedule accurately. Third is tidal system produce no greenhouse gas emission during operation. Then lastly, tidal currents are dense and strong. This means the more energy per unit area can be harvested from wind or solar in some location. And here the four purpose of the system construction for the ocean thermal energy conversion OTEC. First, OTEC can generate electricity all day long because this thermal gradient difference is always available in the conditions. Second, OTEC generate electricity without burning fossil fuel and the system does not emit greenhouse gas or air pollution. Third is OTEC system using open and hybrid cycle can produce clean drinking water as a byproduct. This is especially important in areas where fresh water is scarce. And the last, OTEC can help reduce dependence on imported oil and gas, reducing energy costs and contribution to long-term energy sustainability. Here the working principle for the tidal system electricity generation. Tidal energy system operate by the capture the movement of water caused by the tides. The two most common methods used are as follows. The first is tidal barrage. A dam-like structure is built across a tidal estuary. When the tide occurs and is allowed to flow directly into the storage area called a basin, where the tide ebbs, the water is released through a turbine that is rotated to generate the electricity. The second is tidal stream, is the underwater turbine. This turbine is placed on the seabed in an area with strong tidal currents. Where the water flow past the area is rotate the turbine blade and they generate electricity. This concept is like a windmill that uses blade turned by the movement of air. Both of these systems will be connected to the generator that converts from the kinetic energy to the electricity energy. This operates in two directions of movement, meaning the electricity power can be generated during the tidal process when seawater enter and leave the system. It required by the control system to manage the process of water flow in and out. Here the how ocean thermal energy conversion generate the electricity power. OTEC work by using the temperature difference between the warm surface seawater and cold deep ocean water. The system can operate in three types of the circle. The first is closed circle OTEC. Warm surface water heat a working fluid such as ammonia in a heat exchanger and turn it into the steam. This high pressure steam turns a turbine that generates electricity. Cold deep seawater is then pumped out and used to condense the steam back into the liquid. The working fluid return the evaporator to be converted back into the steam. The cycle repeats itself over and over again. The second is hybrid attack. The system will be used the characteristic of both cycles, open and closed, to maximize the production of energy and fresh water. The system required equipment such as a pump, heat exchanger, turbine and pipe that reach the cool deep ocean layer, which is about 1,000 meters below sea level. This electricity generation process operates continuously and is very suitable for the application in tropical area where the surface of the sea water is always warm. And the lastly is open circle OTEC. Warm, warm seawater is placed into the low-pressure vessel, causing it to boil into the steam. The resulting steam will return to the turbine and generate electricity. The steam will be condensed back using cool seawater to produce fresh water as a byproduct.
Okay, my name is Muhammad Hilman bin Hishamuddin and my metric number is CD240107, and I will present about a discussion of our project. Tidal energy and ocean thermal energy conversion, as known as OTEC, are both clean and renewable source of energy. Tidal energy uses predictable ocean tides to generate electricity, making it a reliable energy source. OTEC utilize the temperature difference between warm surface water and cool deep ocean water to produce power. These technologies are especially suitable for island, nation, and coastal regions with high energy costs and limited natural resources. Both systems help reduce dependence on fossil fuels and lower greenhouse gas emissions.
My name is Muhammad Aizat Zulkarnain. My metric number is DD240092, and now I will present about I will conclude about the conclusion for the Tidal power station. Tidal power and ocean thermal energy conversion OTEC show great promise as clean and renewable sources of electricity. Tidal power takes advantage of the natural rise and fall of a sea level, which make it highly predictable and reliable OTEC. Meanwhile, use the temperature difference between warm surface water and cool deep ocean water to generate power. Both methods are environmentally friendly and could help reduce our reliance on fossil fuel. However, they also come with challenges such as high construction, complex technology, and potential environmental impact. Despite these obstacles, with continue research and development, this ocean-based energy source could play an important role in a more sustainable energy future. This is our reference. First, EIA, Ocean Thermal Energy Conversion, 2023, September 80. This is from journal. Second, in Encyclopedia Britannica, retrieved June 2025. This is a book. And third, review of hybrid web tidal energy conversion technology. This is a journal. And lastly, the journal 2 is all about economic analysis of tidal stream turbine arrays. The publisher is the author is Gus Z. Collis.